My name is Wangila. I'm a professor in chemistry at the University of Arkansas at Pine Bluff here. And my research is focused on various things where my students always do synthesis of compounds which have antioxidant activity. And mostly our compounds have what we refer to as they reduce cancer side effects, and we focus that very much in this particular lab. So what happens is that our students test these compounds in cells to see whether they can reduce those side effects. Especially we induce death of cells using chemotherapy drugs, and then we see whether our compounds can reduce that. And then the compounds which work very well, we go ahead and do more research with them in animals, and especially in UMS, we have a lab that is functional. And we use mice and rats. And what happens that we have been focusing on three things: whether it can reduce side effects in kidneys. Kidneys are always affected when somebody is undergoing chemotherapy. And then alopecia, hair loss, and we also look at kidney storage, especially when people are donating kidneys. We have some compounds that we have synthesized that actually reduce or keep this particular, they keep the, what we call, the organs donated to stay longer than usual. Also, we get funding for this particular research from INPRI, which is part of NIH. This INPRI Arkansas. We also have another thing which we are focusing on in our lab right now. We want to focus on NASA-related STEM research, and we just got a small grant from Arkansas Space Grant Symposium. And they have given us some money to start synthesizing nanostructure compounds which can create energy easily, or they can store energy for a longer time. And our lab will be focused on reducing side effects that are related to these particular compounds. Because what happens that these compounds, when they are synthesized, they produce a lot of radicals, superoxide radicals. And we have seen that our compounds actually remove some of these radicals from natural systems, and we want to apply them in these compounds so that we see whether they can remove these radicals so that energy efficiency can be increased. I would like to introduce my two students who are here today, who are working on this project. We have
Jamila Leonard, and I'm a chemistry major and a senior here at the campus.
Marielle Hunt. I'm a senior majoring in chemistry.
Here we have Ms. Marielle, who is actually planting cells. These are LCCPK cells. And what she's doing, she's going to ensure that they are planted, and then we will put them in the incubator at 37 degrees centigrade with a flow of oxygen of 5%, a flow of carbon dioxide at 5%. And then eventually after 3 days, we will do the treatment. She will do the treatment. And then after that, we will analyze it on our plate reader to see whether there is any reactivity. And here we have Jamila Leonard, who is looking at cells through the microscope. One thing which we always want to know, we want to know whether the cells are confluence, whether they are full, at what percentage, so that when we are doing treatment, we have to put into account those cells, the original amount which were there. And then we make a subtraction of the ones which are dead and the ones which are alive. So the microscope really helps us to determine that. And that's what she's doing to ensure that she has enough cells before we start any treatment.